right, let's take a look at how to find the mean and the median. So if I'm going to find the mean by hand, I'm going to add up all of my data values, x1 plus x2 plus all the way out to xn, and then divide that by n, which is the total number of data values. If I want to do this in Excel, I'll find a blank cell, I'll put an equal sign, I'll type the word average, and then inside the parentheses, I'm going to put my data. Okay, and we won't take a look at that in this video, but in another video from chapter 2, I'll show you how to do that in Excel. For the median, if you want to do the median by hand, you'll put all of the numbers in order from smallest to biggest, and then the number that's directly in the center is going to be your median. And then for Excel, it's a pretty similar idea. You'll put an equal sign, you'll type the word median, and then inside the parentheses, you're going to put your data. All right, so how do we know whether we're using the mean or the median? That's going to depend on whether our distribution is symmetric or skewed. So if our distribution is symmetric, then I'm going to use the mean and the standard deviation. And the standard deviation is going to be my measure of spread for that. Okay, and then if it's a skewed distribution, so I have one side that kind of trails off or has a tail, then I want to use the median and something called the IQR, so the interquartile range, which is another measure of spread. Okay, so for symmetric, we have mean and standard deviation. If it's skewed, you want to use median and IQR. And we'll go over standard deviation and IQR in another video in chapter 2, so you'll see those really soon. All right, so there is one word of warning for these, and that is that the mean is not resistant to outliers, but the median is resistant to outliers. So if something is resistant to outliers, like the median is resistant, then it's not going to matter if there is or isn't an outlier. It doesn't change the value of the median by having an outlier there. If it's not resistant, like the mean is not resistant, then an outlier can really change that value. All right, so let's take a look at a picture that maybe illustrates that a little bit better. So we have 7 people here, and in that first column, there's no outlier. So we have some people that are on the shorter side, some people that are a little bit on the taller side, but everybody's kind of in a standard range there. So if I'm calculating the median, it's going to be the height of this person that's the 4th person over, so directly in the center of the group. And suppose we've made a mistake. Maybe this person on the tall side really isn't 5'10". Maybe they're 7'2", which would make them an outlier. Okay, so now we have a 7'2" person over here. The median is still going to be the height of that person in the 4th position. Okay, so the value of the median, this red line, doesn't change because the median is resistant to outliers. It doesn't matter if there's one there. All right, for the mean, okay, if we look at the set without outliers, so we add up the heights of all these people and then we divide by 7, we get this red line here. Okay, and then if we replace this person on the end that was 5'10" with somebody who is taller, that's 7'2", now I have to add 14 inches to the total and then divide that by 7. And so now my mean jumps up in height. Okay, so that mean has increased in value, and that's because the mean is not resistant to outliers. If there's an outlier there, it's going to impact it. Okay, so let's give this a try. You should see on your notes a list of 19 adults who were asked their age. I want you to go ahead and pause the video, and you're going to find both the mean and the median. So feel free to grab a calculator. Definitely don't add all those up by hand. And pause the video, give those a try, and then we'll come back and make sure we got the same values. All right, so hopefully you gave that a try. To do the median, we would need to put those numbers in order from smallest to biggest. And then I'm just going to cross my way out into the center. So just crossing numbers off from each side until I get to the point that 48 is the number that's in the direct center. So 48 is going to be my median. And then my mean, if I add all these up and divide by 19, I get about 48.57. Okay, so these two numbers, the mean and the median, are actually very close. And that should be what we expect because I have a histogram here of those ages. If we look at that histogram, it is pretty symmetric, right? It's kind of a little bit of a bell curve. And so in a symmetric distribution, we do expect the mean and median to be pretty similar in value. Okay, so that isn't too surprising that we came up with those two. All right, great job.